Welcome to Lesson 5, Safe E-Waste Handling, Collection and Disposal of E-Waste. Lesson 5 forms part of the entire e-learning module that is about second life EV batteries. My name is Madeleine Rabe and I'm a researcher at the Wuppertal Institute. In this lesson, we will focus on the proper collection and disposal of e-waste. Throughout this module, you will gain insights into the significance of safe e-waste management. You will learn about what the end of life of electronic products actually means, and you will learn about the collection, storage, recycling, and disposal of e-waste. Additionally, I will examine the challenges hindering safe e-waste handling, along with the essential factors necessary for the successful implementation of safe e-waste handling. Towards the end of the lesson, I will provide real-life examples for companies that have effectively implemented safe e-waste handling practices in Africa already. Why is safe e-waste handling so important? E-waste is the world's fastest growing domestic waste stream, fueled mainly by higher consumption rates of electric and electronic equipment, short life cycles, and few options for repair. In 2019, only 17.4% of the world's produced e-waste was recycled and collected, which is a very low percentage. This has detrimental effects on humans as well as the environment. E-waste is a health and environmental hazard because it contains toxic additives and hazardous substances such as mercury, which damages the human brain and coordination system. Also, in the absence of a functioning recycling and collection system, many rare, high-value and recoverable materials are mostly dumped or burned rather than being collected for treatment and reuse, which has negative economic consequences as well. If e-waste is collected, recycled and reused, its social and economic potential can unfold. Employment can be created in the recycling and refurbishing sector, and jobs can shift from the informal sector to the formal sector. Health safety is enhanced, especially for children and pregnant women, as they are particularly vulnerable to the exposure to toxic chemicals from e-waste. Children absorb more pollutants relative to their size and are less equipped to metabolize them, and they are impacted most strongly due to their rapid rate of growth and development. Exposure to lead from e-waste recycling activities has been associated with neurological impacts in newborns, changes in lung function, DNA damage, impaired thyroid function, and increased risk of some chronic diseases later in life, such as cancer and cardiovascular disease. Many economic benefits result from a functioning recycling and collection system because high-value materials can be recovered and reused. Therefore, there's a lot of potential for e-waste in a circular economy approach. Electronic waste handling is also a sub-indicator. Safe electronic waste handling is also a sub-indicator for the SDGs and affects many of the SDGs directly or indirectly, such as, for example, SDG 3, 8, 11, 14, 6, and 12. In this lesson, we focus only on the end of life of electronic products, meaning that options of extending the product's lives, such as reuse or repair, have already been exhausted. Of course, circularity and sustainable energy solutions includes more than just the end-of-life handling. The prevention of e-waste during the design, manufacture, and the use stage of electronic products also plays an important role in reducing e-waste and forms part of a circular economy approach. However, this lesson focuses only on the end-of-life treatment, meaning the recovery, recycling, and waste stage of electronics. The first step of proper and safe e-waste handling is the collection of e-waste. This is basically the precondition for all the subsequent steps. The collection and storage is crucial to avoid improper disposal of e-waste, and it determines the amount of e-waste that actually enters the recycling chain. There are mechanisms that can support this process, among others ICT and IoT technologies, which become increasingly important to facilitate and support collection operations. Also, the correct storage of e-waste is essential before and after collection in order to avoid environmental and health hazards. After the e-waste is collected, it needs to be dismantled and separated into smaller parts and fractions. Dismantling means the mechanical or manual disassembly of products, while the separation into fractions refers to the grouping of waste according to materials it is composed of. The subsequent handling, the transport, and the recycling of the fractions depends on the characteristics that each fraction has, as well as on the risk level they pose. For example, lithium-ion battery recycling requires mechanical shredding, while plastics requires careful sorting, as not all types of plastics are recycled at the same melting point. Fractions that contain hazardous or toxic substances are recycled separately. For further information on recycling of waste fractions from electronic waste, you can, for example, refer to the Gogla Toolkit Technical Introduction to Recycling of Off-Grid Products, which you can find in the list of tools in the script. The last stage is the stage of disposal. Disposing of e-waste in inappropriate engineered landfills is less harmful to the environment than incineration or uncontrolled disposal and dumping. But the ultimate goal, of course, is that e-waste should be fully diverted from landfill through reuse and recycle. And it's the main goal that all the materials that can be recovered are actually recovered from e-waste. As our module is about second life EV batteries in general, I also wanted to zoom in on the end of life of batteries from EVs. In the lessons before, we have heard about repurposing of lithium-ion EV batteries, second life battery management, use cases, and the circular design of EV batteries. In figure 2 that you see here in the presentation, you can see a conceptual sketch of the entire life of a battery pack with illustrations of various retirement options. The dark-colored icons show clear capacity fade and stand at the point of the batteries, at the endpoint of the battery's EV and service life. The current EV and battery industries provide 5 possible retirement options. Reduction is already anticipated and not considered a retirement option. In figure 2, you can see the concept of the waste management hierarchy. If the battery cannot be used anymore, for example for stationary energy storage, the end of life of an EV battery is reached. Options then are mainly restoring a battery, which is an option between recycling and reusing, in which cathode materials are restored for battery manufacturing directly without processing. And another option is recycling, which means, as you have already learned, the extraction of valuable raw materials. Recycling should be the last step at the end of life of EV batteries, after battery repurposing and restoration. However, to make the recycling process as simple and cost-effective as possible, there is still the necessity to improve the recyclability of the batteries and all e-waste products for that matter. As you can also see well in the pyramid, incineration and disposal are not desirable options due to environmental and health threats. Disposal is the least energy efficient option. Nevertheless, it is still often necessary, considering that other options may expose workers to electrolyte release and hazardous leaching of chemicals. Incineration has a potential risk of releasing toxic gases that contaminate the air and many other threats. There are still many different barriers to implementing safe e-waste handling. Among these barriers are personal ones, such as the lack of awareness and knowledge about the hazards of e-waste and recommended means of disposal to recover e-waste. An effective enabling environment is still missing in many countries and is urgently needed. The treatment of e-waste in Africa needs to be understood in the context of the scale of domestic as well as imported e-waste. Domestic generation of e-waste in Africa only amounts to 50 to 85% of the whole volume. The rest originates actually from imports from the Americas, Europe and China. Most of the imports are illegal, despite the existence of treaties that forbid the import of any hazardous waste, such as the Bamako Convention. Also, to avoid the high amount of illegal waste imports, the policies need to be enforced way more vigorously. Another barrier are technical barriers, as limited public infrastructure for the collection of e-waste and its recycling, as well as the lack of technology that are hindering the effective uptake of safe e-waste handling. There are also economic barriers that need to be considered. Among those is a clear lack of investment, economic incentives, and profitability to effectively integrate safe e-waste handling into product schemes. For the implementation of safe e-waste handling, it needs to be understood that all stakeholders need to work together. Effort from only one side would not lead to success. Everybody has to do their part. For the implementation and scale-up of safe e-waste handling, an effective enabling environment and policy framework is needed. Policy is the foundation of a thriving e-waste market because it can allocate the cost of e-waste handling fairly among producers, consumers and governments, and it can enable profits for recycling businesses. Moreover, the enforcement of efficient policies needs to be strengthened significantly. As I pointed out earlier before, there needs to be a control of illegal exports of e-waste heading towards Africa and, of course, an effective implementation of already existing policies that should prohibit such processes. Effective business and financing models need to be in place as well. Business models of companies producing electrical equipment, as well as companies that handle e-waste, are heavily dependent on the policy tools chosen by the government. There are two main approaches: consumer financing and producer financing. As the name says, consumer financing approach means that mainly the consumer pays the cost of the produced e-waste. For example, when purchasing a product, the consumer pays a fee in advance, also called the advanced recycling fee, which is used to cover later on the collection and processing of the e-waste. The same concept applies to the producer financing approach, only that the cost for e-waste handling is carried out by the producer instead of the consumer. Other options include public-private partnerships, where costs are distributed between private producers and public entities. We will see an example of that in a company on the next slide, as well as take-back models. Capacity building is crucial for implementing safe e-waste handling as well, because consumers need to be aware about the hazards of e-waste and its improper disposal. Therefore, communication is a central pillar of take-back schemes, and the messaging of take-back schemes should be clear and concise. Awareness campaigns can integrate SMS and radio messaging to reach last-mile communities, the integration of e-waste messaging with marketing materials, a clear disposal of information on product packaging and at installation, and awareness campaigns that can be more effective through collaborations with national campaigns and waste management facilities. On this slide, you can see a practical example of safe e-waste handling, the WEEE Center in Nairobi, Kenya. The idea is that the WE Center is an e-waste recycling company that provides e-waste collection, dismantling, and automated processing services in Nairobi and several other major cities in Kenya. It sources e-waste from the public and private sector and raises awareness through the collection campaigns aimed at individual households. The business model, you will recognize this here, is a public-private partnership in a hybrid form, which means that the WE Center partners with SMEs across Kenya, international NGOs, and the Kenyan government. The company uses a dispersed incentive and collection model, and the center extracts valuable materials from collected e-waste to be sold and reused in the production of other electronics. Another example are Hinckley Associates in Lagos, Nigeria. The idea is that the company is the first registered e-waste recycler in Nigeria, providing end-of-life solutions for electronic equipment, preventing environmental pollution and human harm caused by hazardous e-waste. The business model is as well a hybrid public-private partnership, where Hewlett-Packard and other manufacturers across Africa, as well as the informal sector, are working together.